Hi folks, my name is Rick Searing. I'm a solution architect with Tempered. Today I'd like to give you a quick demo of our Airwall solution. Airwall is a zero-trust software-defined perimeter for your network. Now there's a lot of companies using those same terms in the industry, so let me tell you a little bit more about what we're doing. We allow you to establish this new zero-trust place in your network, could be deep in your network, to protect things that require more security than the typical laptop. So for example, a robot on a factory floor, or an infusion pump in a hospital, or some type of SCADA device that's managing your water system. These are all things that we're in the business of protecting, and let me tell you about the components in our solution that allow us to perform this protection. So first of all, we have gateways. We just call them airwalls, but they're really where we establish that perimeter in the network. We also have agents and server for when you want to connect into those protected devices. We have a relay. Relay allows non-routable networks to connect to each other. This is where Tempered's kind of a networking company even as much as it is a security company, because we can allow anything to connect to anything worldwide with our relay, all through encrypted tunnels. And then finally we have the Airwall conductor. The conductor is the orchestration engine. It provides policy to all of the devices and allows you to easily manage policy in your environment. So we pretty much have an airwall that can go anywhere. It could be a small gateway that you need to put in front of the protected devices that I mentioned. These could be OT devices. These could be sensors that somebody's trying to deploy in your building. Our software runs in hypervisors, public cloud environments, or agents and servers. A simple example that I'll go through in the demo is, if you look on the left, we've got device A, we've got a sensor. You need to connect it to your network at some particular location, and it needs to generate some analytical data that it needs to send to a collector. Let's call it server B over on the right. Today you would connect these to your existing network, and then you'd try to figure out how to secure it, and it would get very complex. You'd have VLANs and ACLs, and you'd have to figure out remote access. So I'm going to show you how Tempered solves this problem with Airwall. We're simply going to allow you to go in and establish a new perimeter in your network right in front of that device. So now we're protecting your internal network from that device, and we're going to allow you to send data from device A to server B through an encrypted tunnel. So let's jump into a demo and I'll show you how it's done. So this is the Airwall conductor, and you're looking at the dashboard, and like I said, it's an orchestration engine that allows you to manage your entire environment. So you can look at all of your airwalls, you can look at who's connecting, when they're connecting, who can connect to what, all within one system. It distributes keys for building host identity protocol tunnels. So let's look at our simple example again. We've got an airwall that's being managed by the conductor. It's got a set of ports. A typical airwall has one port that's connected to your existing network. Everything coming out of that port is going to be encrypted with host identity protocol, completely secure. And then you've got your protected devices that can be segmented into logical groups. Like, for example, here I've got a sensor network on the 1001 network, and I've got another set of devices, maybe my cameras on another network. Once you establish the networking parameters of your airwall, you actually define the devices that are behind this airwall. So in our simple example, we've got device A, which is a sensor that has this IP address. And then over on airwall 2, I've added the collector, we called it server B, off of another airwall. So if I want these two things to talk to each other, again, I've connected them to an airwall. They can't talk to anything yet. It's zero trust. So I'm going to click on this sensor data collection network, and I've added a couple of devices. We could simply add another device here by typing the name of that device. So if we say server A, I can click on that device and I can add it to this group of devices that we want to give connectivity to as well. At this point, we just have a set of devices that have some relationship. So a couple of, a device A and a couple of collectors. Now if I want device A to be able to send data to server B, all I have to do in the conductor is select device A and click trust for device B. At this point, the conductor is pushing policy down to these two airwalls and establishing an encrypted tunnel across the network, as long as those airwalls have reachability to each other. If they don't, that's where the relay comes in and allows them to route to each other, even if they don't have network reachability. So now you can simply see device A now has connectivity to server B. Let's say we've got a remote engineer that also needs to access device A and perform an update or look at maintenance activity on that device. Same thing, I can now go into the engineer's agent that's running on their laptop and just say, oh, I want them to be able to connect to device A. Now they can connect from their laptop into that device. We show it simply here, and this could be a group of engineers, not just one engineer. And now they would be able to reach device A. This has been a simple example of connecting, a couple of devices, device A to server B. We can also do this at scale. So for example, if I go into another network I've built, I've got a group of engineers, maybe spread across 25 different locations. And if I want to give them connectivity to, let's say, an industrial control system network across 183 buildings, it's the same amount of effort. If I just click trust, I've just given them connectivity to those 183 buildings, as long as we've established that Airwall gateway in those buildings that are protecting that industrial control system. So that's how it gets done at scale. We really try to simplify how you can build networks with Tempered's Airwall solution. Now let's look at some additional use cases. Let's talk about the next use case for Tempered's Airwall solution. And let's dig into Airwall agents in a little more detail. Typically, Airwall agents are used to access a device. Once we secure something, it's protected behind an Airwall, nothing else can get to it. Then we've got to figure out, well, who should legitimately get to that device? And those folks would use an agent. So we have agents that run on Mac, that run on Windows, iOS, Android. And typically, they can be located anywhere in the world, and they'll connect in through a relay. They just need outbound access to the relay and the conductor on a public IP, and then the relay will stitch together the encrypted tunnel connection coming from the Airwall. So user onboarding with Airwall agents is really easy. You simply point them at a user portal. They go in, they select their operating system, download the agent, a one-button activation set up so that it'll automatically onboard them. It'll push down the cryptographic ID that makes this agent unique. Nobody can share their agent with somebody else. This is the cryptographic ID that comes from the conductor that leverages host identity protocol that makes this connection much more secure. And then on top of that, I'll show you how we can layer on multi-factor authentication as well for the solution to make it even more secure. Let's say somebody else gets a hold of this laptop. Earlier, we looked at an overlay network where a group of engineers could access a particular device, and we'll use the same scenario here. If we look at the agent from the conductor's perspective, once it's onboarded, you can remotely manage that agent from the conductor. You can upgrade it. You provide policy. You can never give itself policy. So you have complete centralized management for your agents. And you can always see within an agent what networks is it part of, what relay policy does it have, what software release is it running, and that sort of thing. Let me go through a couple of sample scenarios. One might be, we have a concept called device groups and smart device groups, where you could, for example, give somebody 4-hour access to an environment just by dropping a tag on their agent. So let's go through that example here. I've got a group called engineers. It's a smart device group. If I drop a tag on it, it automatically adds people to that group. Let me get pre-established trust to the device A sensor for that group. Now I can just go over to my agent and simply go in here and drop a tag on them, and I'm just calling it 4-hour access. So I drop a tag on that user. That immediately puts them into this smart device group, and if we go back to that overlay, they're now in that group and have trust. So if we pop over to this user, they'll immediately be able to connect to that device. So behind the scenes right now, what it's doing is establishing shotgunning to the relays, figuring out what relay it can connect through, and then building that encrypted tunnel through the relay. It doesn't matter where this agent was located, and you can see I've got connectivity to the environment. Now, if you go look back in the conductor, if I want to remove connectivity for this particular user, or this whole group of users, I could just take away the trust. If we pop back over here, you'll see their connectivity is immediately removed. So the same thing would happen when this 4-hour timer ticks down, their access would be removed. So you'll also notice user authentication is disabled for this user. So we could go in to the agent itself. If I click Edit Settings, I can go down here and enable Airwall agent authentication. So if I select that, you can choose from anybody that supports OpenID Connect. I've got it set up for Azure AD. Could also use Auth0, OneLogin, Okta, those sorts of things. So now you have a second form of authentication as well for your Airwall agents. Next, let's look at a use case where we do east-west segmentation within a single Airwall. So if I go into an Airwall, recall how I could go set up different ports that have different devices secured and segmented behind an Airwall. So if the Airwall gets a packet from these devices, it won't go anywhere unless it has policy. Let's go through a quick example of building a network where a device on this sensor network needs to talk to a device on this camera network. So I've already defined the devices, and here's a couple of examples. We've got a camera monitoring system. Let's just have device A set up connectivity to the camera monitoring system, for example. So we'd simply go into the overlays. We'll add a new overlay, make it a manual network, and we'll call it east-west segmentation. Now I'm simply going to add my devices. So I think it was device A, sensor, and we want it to connect to the camera monitoring system. So we'll just add those to an overlay. Now we're building devices can be part of multiple overlays, and we'll just select the camera monitoring system, and we'll go ahead and give it trust to the sensor. That's it. Visually you can see, hey, these two things now have trust. They were part of two segmented networks, and now they have trust. It's that simple with Tempered Airwall solution. Next, let's look at a situation where you may want access to an entire network. So far you may be thinking, wow, I've got to add every device to my network one at a time. This is going to take forever. So let's say we want to access all of the devices in a /24 network, for example. We can go into an Airwall and define a device as an entire network. And then we can also block access to a particular IP within that as well. So let's go through that example. So over in Airwall 2, we've got an IoT network consisting of this whole /24 network. So again, we'll go in, add a new overlay network. We'll call it network objects. And we'll add our IoT network in building 2, and we'll add device A from building 1. And we'll also add the individual device like server A in building 2. So now if I want to give trust from this device to this whole /24 network in this other building, I simply select that entire network object. And now let's say I want access to that entire building, but not this one particular IP address. I want to block that. I would give it trust, and there's a little block toggle button here. Click block. So that leaves us with, a very easy setup of, hey, device A can talk to this whole network /24, and but it can't talk to this one particular IP address in that /24. So that's how you'd set up network objects in the conductor. In many cases, after we protect devices, we'll often hear from customers that are like, now wait a minute, my protected device does need to talk to this one thing, and I can't necessarily put an Airwall in front of it. Maybe it's an update server out on the internet. Maybe it's a mail server that needs to send out alerts. Maybe it needs to send something to a visibility solution. A number of different scenarios. So we've simplified how that can be done by using a bypass destination in the Airwall itself. So here's kind of how it looks. We've got a device down here that needs to reach out. We'll actually source NAT that packet on the underlay port of the Airwall and send it out to that device, allowing it to communicate through the Airwall. So let's look at how that looks in the conductor itself. So the first thing we have to do is specifically go into that Airwall and make sure on that underlay port that we enable bypass. So it's not enabled by default, but this will allow us to turn on source NAT and allow bypass out. The next thing we need to do is create a bypass destination. So I believe I already have one here. So I've got a bypass destination called Google DNS or 8888. You can also do this by DNS name. And so now I can simply go into, let me go into one of my existing overlays and give device A trust to Google DNS. And just to see, so now all I have to do is add Google DNS as a destination or another device, and I would give trust between device A and Google DNS. So let's go look at how does this look to the device A perspective. So I'm going to just start a ping. And you can see it's not reachable at this point. And now I can simply go into the conductor and say, oh, I want device A to be able to reach Google DNS. So we'll pop down back into there. And you can see now device A can ping an outside address. So we make it really simple to say, instead of having to open up everything on the internet, you can just say, oh, I only want it to be able to talk to this particular device. If this device got compromised and tried to reach out to command and control, it's not going to be able to reach any other address. Right now it can only reach 8888. If I turn it off, again, maybe you want to temporarily enable connectivity. A device goes and pulls down a security update, then you turn it back off. It's that simple to turn it back off. You don't have to go through a bunch of router and firewall configuration. And we pop back in. You can see my connectivity is no longer there. So that's how you set up bypass destinations. And again, you can do it by DNS, fully qualified domain name as well. One question I often get asked is, hey, it's great that you're protecting these devices and it's zero trust and nothing can get to them, especially the bad guys. But what about my visibility tools? How do they get access to make sure, we're still looking for malware or something else that might be going on these critical protected devices? The way we do that is we allow you to install Airwall Server on both Linux and Windows, so that instead of using bypass like I showed before, that remote server can establish a secure encrypted tunnel all the way to the Airwall. So everything's encrypted for that communication and allows that visibility tool to reach in and still communicate with those protected devices, as shown here. Let's take a look at how it looks in the conductor itself. So in the conductor, I've got, here's a sample of a visibility tool server. I've got our Airwall Linux server running on this particular server. So again, you centrally manage this. It's got its cryptographic ID for building that host identity protocol tunnel. And again, you can upgrade it. You can look at what networks is it participating in. But now let's say we want to give it access to that protected device. Let's just go into one of the overlays that we built earlier and just give it access to, for example, device A. So again, we just go in, find our device that we want to add. So visibility tool server. And now it's sitting in the overlay, but doesn't have trust yet. So I'm in that visibility tool server right now. If I try to connect to device A, so it's currently not reachable. And now I simply go into select device A, give it trust to the visibility tool server, or kind of the other way around, visibility tool server, trust to device A. And now if we pop in and take a look at, you can see now that server immediately has access to that trusted device. So what happened behind the scenes is the server built a tunnel to Airwall 1, and all communication between that server and this protected device is encrypted to that Airwall. You can see there's a number of use cases here that we cover a lot of different scenarios with the Tempered Airwall solution. Now that we've talked about a number of the different use cases with Tempered, let's do a little bit of a drive around the conductor to look at some more of its features and capabilities. One thing we often get asked is, what about redundancy? It seems like the conductor is pretty important. So we can go into the settings in the conductor, and the conductor can be deployed in HA. In fact, you could spin up another backup conductor in a cloud environment automatically from the conductor, and it'll automatically stream and sync so you never lose connectivity. Again, the conductor is never in the data path, but we do expect most people have their conductor up, and especially if you have a lot of agents that are moving around, the conductor is coordinating when they can connect and not connect. It's good to have those online all the time. So we have HA high availability for the conductor, also for the Airwall itself. So any Airwall, especially if you were looking at a head-end Airwall, you definitely want to go set up an HA pair. So you connect them with a cable, bring the local devices into both gateways, and now you have redundancy for the Airwall itself. Let's look at a few more things in the conductor setting. So in the conductor, this is where you would do all of your system updates. So I can check for updates. It's going to reach out to our repository, pull down those updates. Again, I can download those here, and I can manage my network. Typical network management functionality, but all nicely centralized. Can push out updates to everything right from within the conductor. Email alerts is always important. We can alert on a lot of different things. So for example, if I look at some of the alerts I have set up, I can not only keep track of my airwalls in the environment, but I also might want to, maybe I've got a critical device and I just want to ping it, it's protected behind this airwall, but now I want to ping it every 2 minutes, and if it's down, I want to alert or take action. And some of the actions you can take within the conductor are pretty elaborate. I can both send an alert like email or text. I can also enable or disable something. Like let's say something's no longer responding. I could disable that overlay so nobody tries to connect or something suspicious going on. I could do an HTTP post to another system. Maybe you want to integrate logging into another system. We also support syslog. Or maybe I want to add or remove tags. So that could help me tag something and say, hey, this thing went down. Maybe it's a very intermittent problem. You want to track it down. So a lot of flexibility in both the event monitoring and alert system within the conductor. Next, we've got tags. So we talked earlier about tags can be dropped onto particular objects to give them access for a certain period of time. There's a lot of additional power in tags. I could have a very elaborate network that I want to go in and just say, okay, at anything related to this complex overlay network, I want to disable it. And again, tags could be triggered via an API call to the system. So now you can automate functionality. We've detected a problem over here using another system, hit our API, disable communication for this part of the network. Makes it really easy to segment and control problems that might show up in your environment. For the Airwall itself, we've got a lot of really rich diagnostics. So, over time, we're building overlay networks, but we often have to deal with the underlay, the existing network. So we put in a lot of rich testing. I can go in and, hey, can I reach my devices from the Airwall? It's a logical demarcation point to try to test whether or not you can connect to different things in the environment. We can also, see whether or not we can ping our peers, or whether the relay is reachable from this particular device. And you could have multiple relays deployed around the world. You want to see which one it's going to use and what's its score based on how it's connecting, for example. We can also go in and do packet captures. So packet captures can be done at any interface in the system, do some filtering, grab that packet capture off the device, download it, look at it in Wireshark. So really helpful for troubleshooting various networking scenarios. We also have diagnostics in the form of a diag report. So if you're a typical network engineer, you're used to logging into a CLI and typing show space question mark. So think of this as all of our show commands. So run a diag report. You can look at ARP tables, routing tables, all the deeper details within the Airwall itself. Support bundles are really handy for uploading. You run into a particular problem in your network, you want us to take a look at it. We allow you to encrypt this file, send it to us. We're the only ones that can look at it. We take security very seriously. You can see under reporting, we've got a lot of graphs and data to show you kind of what's going on real time with any particular Airwall. Lots of rich data and traffic stats to always kind of keep an eye on what's going on in the environment. We do support intrusion prevention as well in the Airwall, so we can look for various snort signatures and again trigger actions based on the detection of that particular signature. If we go back to the conductor, a couple of things to touch on again. Note we can link to an external authentication provider. This could be for access to the conductor, because obviously the conductor gives you a lot of power. It's all centralized control. You can segment that with different role-based access control, but you might want to link this authentication for getting into the conductor to something like Azure AD or again another OpenID Connect provider. You can customize the certificates that we use. Again, we can export to syslog. So lots of kind of advanced capabilities. We've got an audit log that's available here under PCI reporting. So you can see the product's quite mature from a visibility and diagnostic capability. Again, you can take a look at your network as a whole, how much traffic is going through it, what Airwalls are running, what particular models. Again, a lot of kind of visibility of what's going on in your Tempered network. So hopefully you've enjoyed this tour of the conductor and Tempered's Airwall solution. Thanks for listening, and have a great day.